Hello everyone, this is Team2 and you are watching our 11th week's video. This week, we are going to look back on the construction of the roof structures of the Hyundai Seoul and to talk about the issues during the sequence. The roof structures of the Hyundai Seoul is an architectural element that best represents the design of the building. As you can see, it consists of 3 huge kite structures and 8 cranes supporting them. The roof of the Hyundai Seoul is supported by the cranes and cores in order to form a large space without columns. Each crane supports the load of the truss transmitted from the 4 vertices of the kite, and the load is transmitted to the ground by the load bar connecting the crane and the ground. The roof construction sequence is largely divided into 3 parts. The first part is preliminary planning and temporary works. The second part is installation of components. And the last part is measurement and performance management. Many considerations have been made because these crane and kite structures are installed on a large space without columns. Instead, the structure itself has a special load distribution. First, in the initial design, the crane was a structure in which the 2 arms were gathered at one support point, and this force was transmitted to the vertical core as shown in the figure. And the crane supported the whole truss load. However, the design has been changed to the current structure for more efficiency and stability. It now supports only about 20% of the actual load. Another issue during the planning was changing the sequence of the installation. According to the report written in 2010, the order of the construction was the way in which the crane structures were first constructed, and the main trusses of the kite were connected to them in the air. However, the actual construction sequence was that the kite trusses were built first using temporary band structures, and then the cranes were installed before the bands were dismantled, which is presumed to be a change in consideration of construction stability and the lifting capacity of tower cranes. In general case, roofs are constructed on the hard structure such as columns and beams. However, in the case of the Hyundai Seoul, there was no columns to support it, so temporary band structure was needed to install the roof structures. When the construction of the building was completed up to the 5th floor, temporary areas for the installation of the bands were built over the 5th and 6th floors. First, as you see in the case of the 5th floor, temporary steel frames were installed in an empty space between the slabs for the installation of the bands. And the 6th floor was not built perfectly at that time, so the temporary structures were installed where the actual structures should be built. Then they merged with them after construction. 47 bands were installed on the temporary space and existing slabs, and they were basically installed on a separate reinforcing plate on the steel frame and bonding them to it. When they had to be installed in the slab position, the reinforcing plate was extended to the steel beam. Since the load of the band was applied on the structure, the existing slab was reinforced by the cantilever. Each band was arranged to distribute and support the load of the kite properly. After all the bands were installed, they started actual kite construction. One kite is largely composed of 3 main trusses and several sub-beams and pulleys that distribute loads, and each structure was completed using the prefab method, so only the lifting and installation work was carried out at the field. Since the kites are very large and heavy structures, each truss was split into several parts that could be lifted by tower cranes. The carried trusses were installed to fit the position of the band and then bonded in the same way as shown in the figure. Each part of the main chassis was assembled with the same time truss, and the joint between different type trusses are welded to each other. Sub trusses were joined with main trusses by bolting method, and the points at which these trusses intersect were joined by splice welding. Trusses were installed in order from outside to inside and worked from the hotel side to the tower side. Through this work, a huge kite-shaped roof structure was completed. At the time the main trusses were installed, the installation of the crane began to support these trusses. Each crane consists of several parts, with the shape of a triangle in which the front and back arms are narrowed upward, and these arms are joined in the lower torso and supported by leg parts. Tie beams, top bars, and leg braces exist to disperse the loads and increase stability. And this structure makes a special shape and makes the most significant design of the Hyundai Seoul. The crane was also manufactured in the prefab method like kite structure, and at the construction field, lifting and installation were performed by each part. There are some issues with the construction of the crane. First of all, the largest truss part for the kite was about 7.3 tons weight, while the hard portion of the torso part of the crane was at least 15.7 tons, which is twice the weight of the truss. As a result, it was impossible to lift with the tower crane that was constructing the existing structures, and thus 6 of 550-ton mobile hydro crane were installed. The hydro cranes were installed in each location, and they were very heavy to affect the ground of the building. In order to prevent this influence, the load had to be dispersed by mounting a support steel beam and an outrigger. Meanwhile, the separated segments were installed in the order of torso, leg, front arm, tie beam, and back arm, and it took 4 days per each crane. During the installation, they ran a 3D scan to measure the construction error. It was confirmed that there were some errors of location, angle mismatch, and misalignments of the joints. To correct this, some sections were reinstalled, and a separate reinforcing plate was installed for the joint to secure the stability. Finally, a backstay rod was installed to connect the crane and the ground layer of the core. The backstay rod is consisting of 4 stranded rods about 50 meters long at the outer end of the crane, which is directly connected to the core to support the load of the kite on the front part. The backstay rods were constructed by calculating the deflection due to the tension caused by self-weight, even from the beginning of installation, and the tension value was reviewed as the construction progressed. After the main truss and the crane were completed, they carried out their finishing work, including the dismantling of the bands. Since the load on the truss was still supported by the bands, the dismantling was carried out very delicately. Whenever one band is sequentially removed, the load is redistributed to the other bands, cranes, and core structure. So the load received by each structure is checked in real time to ensure stability. After the bands were dismantled, sub-beams and purlins were installed on the truss, and the membrane material was overlaid on the top of it to complete the Hyundai Seoul's roof as we know it. The crane and the trusses were very heavy for the roof structures, but they used an unusual load distribution method without columns and using tie rods, which required more detailed construction management than conventional buildings. The constructor actively introduced SHM, which refers Structure Health Management, as part of their smart construction. And the tension and deflection of the structure were reviewed through a BIM simulation and checked in real time through a tensioner and a temporary strain gauger. They analyzed additional loads occurred at each construction stage of the building, and the result showed that there was a severe fluctuation for about 3 months from the time of the band dismantling to the stabilization of the structure. The loads increased with each stage, such as reinforcement, curtain work, and finish work. In the last landscaping work, the deflection showed a decrease, which is presumed to be due to the expansion of the steel cross-section as the temperature rose. On the other hand, in the case of the cranes, there was little change in deflection due to additional loads from the stable point, but the actual tension applied to the backstay rod was found to be larger than the analyzed tension, so reinforcement was considered. Fortunately, thanks to the change in the design of the crane to enhance stability, the work was completed without additional reinforcement work since the actual tension was in the range of the design strengths. In conclusion, the roof of the Hyundai Seoul required delicate and complex work due to its unique shape that was not easily seen in existing architecture. In particular, BIM-based smart construction contributes greatly to its accurate work by calculating its complex load distribution with a minimum error. On next week, we will talk about the slabs and the curtain walls of the building. Thanks for watching our video.